The broadcast is now starting. All attendees are in listen-only mode.
Sorry, I guess I was muted, so we'll redo that again. Welcome to session 2 for today's webinar regarding TopSolid 2021 new product improvements. In this session, we're going to be going over some improvements to do with tooling, cutting conditions, and machine part setup documents. So, as usual, if you have any questions, type them into your question bar and we will do our best to answer them as we go. So let's get started. So there's an improvement with regards to abacus documents and regards to exceeding cutting conditions. Okay, so what does that mean? So when you have a specific cutting condition, so for example, we go into here and you can see that we have specific cutting conditions for our depth of cuts, our radial and axial depth of cuts. If you go outside the range of what you have here, do you want to allow TopSolid to interpret and provide values? So allowed out of range values. Or do you want TopSolid to throw an alarm? So if we select this and we go into here, meaning there's no values there, so it will produce nothing or throw an alarm. To show you what I mean here, if I go back into the allowed range and I go to search and I go to here, let's try this one. And if I do 5 and 5, for example, 5 millimeters, 5 millimeters, you can see here we have value. If I go here and I do 20, you can see here 0 and 0, but it's allowing a value. Okay, so empty cells allowed. This means that it will output 0, but the operation in TopSolid will not be invalidated. If we go here and do the same thing, and we say 5 and 5, okay, again, we're good. If we go up here and say 25, for example, you're going to receive this, which means it's non-value. Okay, so again, if you're using abacus documents, it's just a choice on whether or not you want it to produce or allow the values to be interpreted or out of range values to result in an error. If you leave this document unchecked, that means that inside of TopSolid'Cam, if you're using an axial radial depth of cut that's outside of the range of your abacus document, then you will not be able to generate the toolpath. It's blocking you from doing something you can't do. Okay, perfect. Let's keep on going. Okay, so specific cutting conditions linked with an abacus. So in the past, it was very, very difficult to determine when you have specific cutting conditions, like here, we have specific cutting conditions for tools, to know if it was also tied to a specific abacus or not. So let me shrink up some of my windows here. Okay, we can link this. So we know this is coming and also linked to the end milling, side milling abacus. So if I go to my abacus in here, it's linked to that abacus there. So the other place that it will show you this is in the file itself. So let's bring these back over. And if we go into here, to know that a cutting condition is linked to a specific abacus, when we go into our cutting conditions, the first thing it tells you is this. Before it was just dots. Now a star tells you that it's linked to an existing or specific abacus, as well as it lists it right here. So here's the name of the specific abacus. Okay. Perfect. Okay, so tool life management, or tool/insert life management. We've had some improvements on this as well. So 3 new major options have been added to this feature. Let me just bring over my little cheat sheet notes here. The possible application to a specific operation, that's first one. So instead of just optimizing the entire tool, we can optimize it for specific operations only. This works in both milling and turning. Possibility to hide the child operations. This is to avoid the creation of multiple operations. I'll show you guys that live in a second. And then a new step number cutting type is available. So we want to change out the insert. We're going to consider it worn out after 2 passes, for example. Okay, so let's have a look at all of these wonderful samples. So to begin with here, I'm going to just take this first operation. We'll right click, go to lifetime management. I'm going to activate lifetime management. Here's that first operation. I'm doing it for the entire tool, all operations that tool is used at, or only certain operations. Okay, this one's kind of boring. It only has 1 operation, but you get the idea. And then from here, are we optimizing the tool or the insert? I want to optimize the insert. If I'm optimizing the insert, do we want to specify a specific tool change position? And I have a insert tool change position defined in my tool change positions. You can define that in that icon right there. You can specify how long it takes your operator to change the insert. And then lastly, in here, I'm going to say after 2 passes, let's go ahead and do this. Okay. And then first we're going to create the child operations, and then I'll show you what it looks like if we don't create the child operations. So child operations will look like this. You have multiple operations because it's breaking it down into the 2 operations. Okay. If we go and simulate, there's step 1, step 2, and now this is coming out, going to our insert change location, right? And then it's going back and doing its machining. Okay. Now, if I go back into, and you always right click on the tool to get into lifetime management, if I uncheck create child operations, it keeps it as 1 operation, but it includes a new symbol. I'll try to zoom up on the symbol for you to show you where the toolpath is being cut. Okay. Now, the downfall of doing this as 2 separate, or of hiding the child operations, is then you don't have easy management of link movements. Okay. If that's not a big deal, then do it this way. If it is a big deal, do it the other way. Okay. If we go to the next turning operation just for fun, I'm going to execute it once just so it's up to date. Let's go ahead and do a lifetime management on that one. In this case, you can see there's 2 operations now with that tool. So I can optimize all or just the one. So I'm going to say just this one for now. And I do want to do this with child operations because that's the way I like to go. We're going to insert or do an insert change. And here, if we zoom up, let's see. We select this. Can we turn you on? There we go. Turn you off. Yeah, we'll leave it at 2 or so. And now you have your multiple passes. Okay. So those are the 2 improvements, or the 3 improvements, I should say, for the tool lifetime management. Let's keep on going. Lastly, we have a new tool type supported, a high-speed mill or a high-feed mill. Okay, so here, this is a new tool type, and I'm going to run a video on this in a second, but I want to bring up a cam file first, and I want to talk about one limitation with high-feed mills. If we go to the equipment, you see the high-speed mill here. There is no generic for high-speed mills because there are too many geometric differences that exist in these tools out there. So it only exists by a user-defined tool. So you have to define by either modeling up or by downloading from your tool supplier the 3D model of this tool. Okay. Now to review the 3D model for this tool, I'm going to load up a video here. Sorry, it's on my other screen. And off we go. So shank is the shank. You guys should all know by now how to define a tool shank. So nothing special here. You have the standard definition of a tool shank. After that, I'm just going to fast forward that. So after that, you have, of course, the definition aspect. Again, this isn't new to anybody. So now let's go to the cutting part. So from here, you can see that there are many elements in that profile. So we're going to simplify that. For those of you that don't know, anytime you're making a section for the tool definitions, if those sections have a ton of profiles, it makes it harder or it makes it so TopSolid has to work harder when you're doing collision detection or material updates or what have you. So here we are just trying to simplify as much as possible. Okay. So here we have the different radiuses, the different angles. Fast forward a little bit. So now when we go to define the mill, let's take a look at how that works. So the cutting diameter, we're just going to create a parameter on the fly from here to that point there, measured relative to X, call it whatever, it's radius 1, and then we'll multiply that by 2 to get the diameter. Okay, cutting bottom diameter, again, let's take a look, call it R2, from here to that point. Okay, again, measured in X, times 2. So cutting length now, and you could have had all of these things, all these values measured already. You don't have to make parameters on the fly if you don't want to. This is just our way of showing in a video how we're getting our measurements. And that's going to be relative to Y. Okay, cutting angle 15, corner radius is going to be that. Okay. As far as the frame is concerned, it's a cutting edge origin frame just like any other milling tool. Perfect. From there, you're going to use the shank frame, and this one is set up so these inserts go into that holder in a specific location. And of course, now you're going to select your revolution profiles. Okay. And then lastly, we're going to set the correct driven point message. We're going to make sure that our cutting directions are correct. So origin Y for both should be correct. And then it's the normal plane compensation and point compensation. Okay. So after that, you build the assembly, which again, I'm just to win time since you guys have all built tooling assemblies. I'm fast forwarding a little bit, but there's your tool definition and it is ready to use. Alrighty. Okay, so that's it for tools and cutting conditions, I believe. Let me check my notes. No, a couple more little things. I don't have videos for or really samples needed, but you can copy an abacus between two cutting condition documents now. Okay, you'll see these options in your abacus documents. It has to be a copy and paste into another document of the same type, just so we're clear. And then one other minor little improvement is in the tool catalog column. So when you're searching inside of TopSolid'Cam for a specific tool in your library, you can now set filters like you could in the tool manager previously. That came out in 7.14. Okay. And then last thing, the advanced parameters for generic tools. Here we're talking about these parameters. You have the choice in your tools options, cam options, and then tools to have it either not collapsed or have it collapsed. Okay. And that's these areas down here. So whatever you want your default to be for that. Okay. So machine part setup document improvements are next. Let's go there. So first thing we're going to talk about is the automatic healing update. Okay, and what do I mean? Let's go and turn this on. In your document options, let me go turn those on really fast here. In the update section, this option exists in all the other document types. We've just added it to the machine part setup document type. You can have the healing update active or not. Okay, so with the healing update not active, pardon me, if I delete something here, you're going to get a rebuild error because it's looking for you to solve this issue. Okay, because now you have a constraint that doesn't have a part to be constrained to anymore. If you have the healing update turned on, the software automatically deletes that constraint for you. So minor improvement, but it at least gets rid of manual steps if you're making a change. Okay. Next, set up part definition rules. So we have been slowly making changes to how a machine part setup document functions. Last year, we told you to stop creating your solid model of your finish and the solid model of your stock in the same part file and including them in the representations and bringing them forward because it causes issues. Now the same thing for assembly documents. So if you create an assembly of everything like I have here, and I want to create a machine part setup document out of this, you still can do this, and this is the proper methodology, by the way. If you need to build an assembly, then send it to a machine part setup document. Okay. Do you want to disassemble the included assembly? So the new requirement is this: you must disassemble the assembly in order to be able to select individual objects. Okay, so watch what happens if I hit no. If I hit no and I come into here, I'll deselect this once. That's what you used to do. And then you could try to use rotative selection to get the individual shapes. And right now I'm holding my left button down, I'm tapping my right button, but it's not allowing me. We are forbidding you from selecting this way. Because again, right now, this is an assembly. Therefore, it is a group of objects. No longer can you select or lie, cheat, and steal, so to speak, and select through the group to get the local object. In order to do it, what you must do is during the creation of the MPS file, click yes to disassemble, or if you forget, come back to modeling and come into here, choose disassembly, select that. That effectively breaks the assembly structure, so it's now just a bunch of shapes. And now when I go to my edit part NC command, we can get rid of that, and you see you have each of the individuals, so I can take the stock down to there. I can control select the clamps, bring those down to there, and now we have a nice clean machine part setup document. Alrighty. So here we go. Let's keep on looking at new improvements. Next one, and this one's kind of cool. This is a new document type that allows you to create margin rules for either cylindrical or rectangular stock. Okay, how does it work? I'm going to show you everything, and then we're going to create one kind of on the fly. So I have a part, right? My part is 3/4 inch diameter, 1/2 inch long currently. If I go and create a machine part setup document for this, I'm going to come into my normal settings here. I'm going to say that, you know what, I'd like a cylinder. I want to use stock margin rules document, and I'm going to choose my 6061 cylindrical margin rules. And now it has read the margin rules to determine how big my stock is supposed to be. Okay. If we go and make a change to this, for example, I make this 2.5 inches, and I make my diameter 1.5 inches. This updates according to my rules. And now let's go look at what my rules are. So if I go open the rules document, first thing that's important to understand, these rules are defined based on material. Okay, so you must A, define the rules based on a specific material, and B, make sure in your part file, if we go back to my part file, that you have the material defined properly as well. Okay, from there, you have ranges on the diameter and then on the lengths. Okay, to add a new range, for example, you just click, it's starting here. Okay, and then the range goes to here, let's say, including that value. And my amount of stock on this is going to be that, for example. Okay, so that's how you make, or how you would add fields to this. Now, if I go and create a new rules document, just so that you see the process completely, document, under advanced, I believe. Oh, nope, I think it's under special. There you go. Here you see there's one for cylindrical. There's also one for box margin rules right here. Okay, they work very similar to each other. So this is going to be 6061 live. Good enough. First things first, I need to be able to add the material. So here I have the material in my project. If not, you would go to your library, grab it, drag and drop it right into there. Now that material or materials are defined. So yes, you can drag and drop multiple materials into there. So if this set of rules is good for all grades of aluminum, for example, great, put all your grades of aluminum in there. And then from there, you start adding your margins. And that's pretty much it, okay? From there, it acts just like what I just showed. And again, you can do this for circular stock or cylindrical stock, I should say, as well as box stock or rectangular stock, whatever you want to call it. Okay? Cool. Let me check my notes here because I think that's the end of this session. Oh, nope, one more thing. All right. One more thing. Let's go find a operation. No, that's boring. That one works. So we made another little improvement. Maybe you guys saw me use this earlier in one of the other webinars. But down here in the bottom right-hand side of your graphical section of the screen, there's two new icons. This one hides and shows stock. This one hides and shows the finished part. So the only way you could do this before is by right-clicking either on the part, hide or show finished stock, right? Doing it up here, hide, show finished stock, or in the entities tree, you could turn it on and off. Now you just have a simple to use icon which hides or shows everything. Okay? And I think that's it. So from there, does anyone have any questions that weren't answered? Let's have a look. Nope, it seems all of them got answered. Cool. So then that concludes this webinar, and we will be continuing at 1 o'clock Central Time with the next session. In that session, we'll be talking about virtual jogs, link movements, and some simulation improvements. So until then, have a good lunch if it's your lunchtime, and we'll talk to you then.